Hello there, Mr. Sutton here, bringing you the IM3 Honors 1-6 Part 1 homework solutions on transformations. To graph this square root, I'm going to first start with a table of values for the original function, 0, 0, 1, 1, and 4, 2. Those are the points I always use for square root. And then I'm going to transform them. This minus 7 is just shifting the whole graph down by 7 because it's outside, so it's a y value and it's what you expect. So down 7. So when I rewrite my table of values, the x's aren't going to change at all. All it's going to change is I'm subtracting 7 from my y values. So I'll just rewrite all the x's, 0, 1, and 4. Now for the y values, let's subtract 7. 0 minus 7 is negative 7. 1 minus 7 is negative 6. And 2 minus 7 gives us negative 5. Graphing those 3 points, we have 0, negative 7, so there's 4, 5, 6, 7 right there. And then 1, negative 6 is right there. And then 4, negative 5 is going to be right there. Since 0, 0 turned into 0, negative 7, and 0, 0 was the regular starting place for this function, we're going to start our new function at 0, negative 7 and go one direction the other way through those other points. To graph this square root function, I'm going to first make a table with my parent function's 3 points that I always use, 0, 0, 1, 1, and 4, 2. And then I'll transform each of those points according to this function. So taking a look at what's happening here, we're adding 6 inside the square root function. So that means we are going to be shifting left 6. And then the plus 3.5 outside means we're shifting up 3.5. So in terms of x and y values, that means my x values, since I'm going left 3, I'll have to subtract 6 from all those. And for my y values, going up 3.5 means we're doing y plus 3.5. All right, let's change each of those now. So we do x minus 6 to each of the originals. So 0 minus 6 is negative 6. 1 minus 6 is negative 5. And 4 minus 6 is negative 2. And then adding 3.5 to the y values, we've got 3.5, 4.5, and 2 plus 3.5 is going to give us 5.5. Putting those on a graph, we have negative 6. Let's see, that's negative 6, yep. And then 3.5 brings us up here. Negative 5, 4.5 is right here. And negative 2, 5.5, that looks like right about there. Negative 6, 3.5 is our endpoint for our square root, since this was originally the point 0, 0. So we're going to start here and go through the other points in one direction. To graph this square root function, let me start with my table with my 3 points, 0, 0, 1, 1, and 4, 2. And based off of this function, with the minus 2.5 inside, we're shifting right 2.5. Plus 5 outside means we're shifting up by 5. So putting that in my table, that means my x's each have to get 2.5 added to them to go right. And then the y values have to be increased or added by 5. So applying that to my x values, 0 is now going to be 2.5, 1 becomes 3.5, and 4 plus 2.5 is 6.5. For the y values, 0 plus 5 is 5, 1 plus 5 is 6, and then 2 plus 5 gives us 7. Putting those on the graph, we have 2.5 right there, and then 5 is up here. There's that first point. That's where it's going. The square root's going to start. That was originally 0, 0. Now it's been moved here, so this is my end point for my square root graph. Next we have 3.5 and 6, and then we have 6.5. Let's see, that's 5, 6, 6.5. And this will be 7 right up here, right here. There we go. All right, so starting here, going one direction through all those, there's our new graph. For number 4, we have an absolute value graph to transform. Here is our absolute value 3 points that we always use. And we're going to be shifting up 4 with this plus 4 outside the function. So x is going to stay exactly the same, but the y values have to get 4 added to all of them. So for x's, we still have negative 1, 0, and 1. For the y values, we now have 5, 4, and 5. So we've got negative 1 comma 5, 0 comma 4, 1, 5, and draw the v through those. For this problem, we're shifting an absolute value graph. Here's the absolute value table again, and we're going to be shifting to the right 4, and this outside one is going to shift us up 1. So in our table, we need x plus 4 and y plus 1. Adding 4 to all the x values, we've got 3, 4, and 5. For the y values, that gives us, when we add 1, we get 2, 1, and 2. Graphing those out, we have 3, 2, 4, 1, 5, 2, and draw the v through those. To graph this absolute value transformation, I'm first going to write down the table of values for the kind of my big 3 points for absolute value. Negative 1, 1, 0, 0, and 1, 1 right there. And now let me just see, based on what the function looks like, what kind of transformations we're dealing with. This minus 3 inside the absolute value is telling me I have to shift right 3, because it's always opposite of what you see in there. The minus 2 outside the absolute value is telling me I need to shift down 2. So right 3, down 2. Let me set up a new table, and I'll just adjust these points according to those transformations. So right 3 means that I have to add 3 to all my x values. And down 2 means I have to subtract 2 from all my y values. So adding 3 to the x values, this negative 1 becomes a 2, 0 becomes a 3, and then 1 plus 3 is 4. Subtracting 2 from our y values, we have 1 minus 2, which is negative 1. 0 minus 2 is negative 2. 1 minus 2 is again negative 1. Now I'm just going to plot these over here on the graph. So we have 2, negative 1. 3, negative 2, and 4, negative 1, and let's just draw the absolute value shape with those 3 points. To graph this square root function, I am going to first write the table of the parent function with 3 points, 0, 0, 1, 1, and 4, 2. Next, I'm going to figure out the transformations. The plus 4 inside the square root means I'm shifting to the left 4, opposite from what we expect. And then the minus 8 outside means I'm shifting down 8. So putting that in my table, if I'm going left 4, that means I've got x minus 4 for all my x values. And down 8 means we have to do y minus 8. So let's do the x minus 4 part first with the parent points here. So 0 minus 4 is negative 4. 1 minus 4 is negative 3. And 4 minus 4 is 0. Next, I'll subtract 8 from all the y values of the parent function. So we've got 0 minus 8 is negative 8, 1 minus 8 is negative 7, and 2 minus 8, negative 6. All right, let's graph all those out. So we have minus 4, minus 8. So let's see, here's 5, 6, 7, 8 right there. And then we have negative 3, negative 7's got to be right there. And then 0, negative 6 is over here. Okay. What's the next thing? Oh, we have to figure out which way this thing's going. So the 0, 0, this got transformed into negative 4, negative 8. So this negative 4, negative 8 is actually the start of our square root, which means we're going to go through the other 3 points in this direction here. For number 8, we're transforming a square root. Here's our original table of values for the square root. In this one, we're just shifting to the left, or rather the right 1. Everything's opposite here. So right 1 and down 3. So that's going to be x plus 1 and y minus 3. Adding 1 to the x's, we've got 1, 2, and 5. For the y's, subtracting 3, that's negative 3, negative 2, and 2 minus 3 is negative 1. Graphing it out, we've got 1, negative 3, 2, negative 2, and 5, negative 1. We know that 1, negative 3 is the endpoint because it came from 0, 0, the original endpoint. So starting here, we're going to just go to the right forever and call it a day. Number 12 is a little bit of a trick problem. Here, triangle r prime s prime t prime is shown on the grid below, and this is the image of some other triangle after the triangle was translated 3 units to the right and 4 units up. So we want the coordinates of point R before the translation. So they're not telling us to translate this thing 3 units to the right and 4 units up. That actually already happened. That was how we got to this triangle in the first place. We actually need to reverse that and go 3 units to the left and 4 units down, and that would bring us to the original R point, which is at -1, -1. Choice D.